So write those three equations down. Write those three equations down. What do you guys remember about elimination on Tuesday?
It took literal forever.
It took a lot of paper, didn't it? Substitution will take a good amount of paper, but it will be shorter. Won't take up near as much paper, but it's still a little bit of a lengthy process. What was the goal when we used elimination? Why did we use elimination? To get rid of one of the variables, right? So elimination, eliminate one of the variables. Substitution, if you remember when we did substitution with two variables last week, how did we do substitution with two variables? If I just gave you an x and a y. Tyler, how did we do that?
We minus the y and put it on the other side.
Yes. So if I had these two equations, when we were talking about this stuff last week, what you would do is try to isolate either the x or the y. So I think isolating the x or y in this first equation would be easier than the second equation, because the second equation we would have to divide by a 3 and a 2. So let's isolate one of these. Let's get x by itself. So like you said, Tyler, we would just bring the terms to the other side. And we would have x equals 4 minus y. Okay. What did we do last week once we solved for one of the variables? Once we got one of the variables equal to something. Then what did we do?
Plug it into the second equation.
So we would plug this in for x right here. Or we would substitute it in, hence the name. So we would have 3 times this, 4 minus y. And then I'll just rewrite what else I have here. And then, notice, we only have one variable now. We only have y. So if we have an equation and one variable, we're really good at solving those, right? When we only have one variable? Yes. So we could solve this. I don't know what this is going to equal. I don't really care about that problem. I just wanted to kind of refresh you on how we did substitution with 2 variables. The process with 3 variables is very similar. It's just a little more work than what we did over there, but it's very similar. So, looking at those 3 equations, which variable in which equation is going to be pretty easy to isolate by itself?
The y in the second one.
That's a good idea. So let's get y by itself in the second equation. So I'm going to write, do you mind if I erase this slide?
Yeah, go for it.
So let's write, I'm just going to write the second equation. So I'm going to write negative 2x plus y plus 4z would equal negative 9. And you told me to try to get the y by itself. So what do I have to do to get the y by itself?
Plus 2x.
So let's add 2x to both sides. What else do I have to do?
Minus 4z.
Minus 4z from both sides, okay? So these are going to be gone, that's going to be gone. Only going to have y. Got my negative 9 right here, plus 2x. And I got my minus 4z. Okay. So first step, substitution. We isolated one of the variables. Again, don't worry about these red steps for now. The red steps are what I'm doing right now, is what I'm showing you. So I'm going to post this on Schoology. If you need to go back and look at the steps again, they'll be there. So, what do you think we're going to do now that we have the letter y isolated? What are we going to do?
Plug it in.
So we're going to plug this whole thing in into where?
One of the other.
One of the other 2. So we already dealt with equation 2. So I'm going to kind of block that out of my mind. I don't care about equation 2 right now. This is my new equation 2. We're eventually going to have to substitute this in to both of the other equations. So we're going to have to do it into the first and the third. So let's start by doing it in the first equation. So I'm going to just write that first equation, but with this as my y. So I'm going to have a negative 6x plus 5 times my y, which again we just found, and then plus 2z would equal negative 11. So all I did was I took my new y value and put it in for the y right here. Okay. So what should I do next? Let's distribute that 5 to each term. So negative 6x, what's 5 times negative 9? Yeah? What's 5 times 2z? Or sorry, 5 times 2x, sorry.
10x.
10x, there we go. And 5 times negative 4z.
Negative 20z.
Thank you. And then I have to bring down the rest. So a good part you'll notice is, hey, I don't have any more y's. All I have are x's and z's. I already got rid of one of the variables. That's good.
Can we add some of them together now?
Yeah, let's add some like terms. Good idea. So how many x's are we going to have? We have a positive 10 and a negative 6. 4x. And how many z's are we going to have on that side? So we have a negative 20 and a positive 2, so like you told me, 18z?
What about 45?
Yeah. Let's get the 45 on the other side. Let's keep the variables to one side and the non-variables to the other side. So I'm going to have to add 45 to both sides. Yes, so negative 11 plus 45 is 34. So our new equation is 4x plus 18z equals 34. If you recall from Tuesday, with elimination we picked two equations, got rid of a variable, and we got a new equation with two variables. This equation here is important, so I'm going to box it in, because I'm going to use it in about 2 minutes. So I substituted y into the first equation. What was the other thing I had to do? Do it to the third equation. Okay. So I'm going to write the third equation. 4x minus 5y, except our y is this. Got a question, Lily?
Is it negative 18z?
Yep, thank you. Good catch. Which part, Reagan?
Well, you had a positive. I was like,
Oh,
whatever.
okay, sorry. Feel free to correct me because I do make mistakes at the board. And again, I'm substituting in my y value for the y right here. So it's going to be
Negative.
yep.
So if you do something to one of the equations, you have to do it to both of the equations, basically.
So,
Oh, see, you have to take the y and do it to the 3 also.
which is what I'm doing now. Yeah,
Yes, so-
yeah. So like elimination, when we did elimination on Tuesday, we had to work with two equations and then two equations again. What we're doing today, we're eventually going to be working with each of these three equations. So I worked with the first one, and I got y by itself. So then I don't care about it. Then like you said, yes, now I have to do something to the other two that I didn't use yet. So this is what I got from the first equation.
When
And
you
then
put
now-
y in. When you
Yeah, I put y into the first equation and I got this. So now I'm putting my y value in to the third equation right here, and I'm going to get what we're working out right now. So let's distribute again. Help me out, what's negative 5 times negative 9?
45.
Positive 45? What's minus 10x plus 20z? Yep. And then bring the rest up. What's that step again, Carrie, like you told me last time?
Add them together like 2.
Let's combine like term. We got a positive 4 and a negative 10x. How many x's do we have? Yep. Negative 10x and positive 4 is negative 6x. 20 z's plus another 5 z's, so we got 25 z's. And what do we do about that 45 on this side?
Subtract that.
Let's get it to the other side, so we have to undo it.
That's
Is that right, so far? So negative 4 minus 45 is what?
Negative 45.
Yeah. So again, we have another equation, but it only has x's and z's. We don't have any y's. That was our goal, and we were successful. So I worked with the first equation, substituted in y, and got this. Then I worked with the third equation, substituted in y, and I got this guy. What do you think I'm going to do now with those two equations with the green dots next to them? So someone said add them, someone said substitute for another variable.
Substitute for another variable. No, but we don't even know what variable it is yet.
So there's two things you could do here. You could isolate the x or the y and substitute it into the other equation.
Isn't that
But-
a z?
The x or z and substitute it into the other equation. But the problem is, if we try to isolate the x, we're going to have a fraction. Because you would add 18 to both sides and you would get, and then you would have to divide by 4, right? So you would get x would equal 17 over 2. By the way, don't write this down. Plus 9 over 2z. I really don't want to substitute this in to the other equation because I have fractions. That is not going to be fun. So instead of using substitution, let's do the method we did on Tuesday. Let's try to eliminate one of the variables given these two. So let's use elimination.
But if it would work, you could do that way.
If it would work without fractions, yes, you could. Or Carrie, if you really wanted to, you could isolate the x like I did and plug that in for the x in the other equation.
With
but-
the fractions?
But I had messy fractions, yeah, so I want to do that route. You could though if you really wanted to. Same thing if you solve for the z here, you're going to get fractions too. If you solve for x here, you get x by itself, you're going to have fractions. 25 by itself, z by itself, you're going to get fractions. So let's use elimination. So we have a 4x and a negative 6x, or negative 18z and 25z. Which is going to be easiest to,
Equation 1. No.
should we try to eliminate the x's or y's? Which one do you think will be easier? I think the x's will be easier because 6 and 4 have a smaller common term than 18 and 25 do. I can't think off the top of my head what number goes into 25 and 18 evenly. I can't think of that. But we know, what should we try to make these x's equal to if we have a 4x and a 6x? I think 12 would be a smart idea. The least common multiple of 6 and 4 is 12. Okay. So how do we get that? How do we get this equation? How do we get that equation all the way to the left? How do we get a 12x from a 4x?
3.
Let's multiply that whole equation by 3. So I'm going to take 3 times 4x minus 18z would equal 34 times 3. So remember, when you multiply one side of the equation by a number, you have to multiply the other side of the equation by a number.
Sorry, I'm lost.
No, you're good.
Where'd you get the 3 from?
So I took this equation. I'm going to try to cancel out the x's. So I have a 6x and a 4x. They're not going to cancel the way I have them now. So remember on Tuesday when we did elimination?
Oh, then the times.
Right. So I'm going to try to get these both to be a 12 and a negative 12. You could make them try to be a 24 and a negative 24. That could be an option, but you're going to have bigger numbers. So I'm taking 3 times both sides of the equation. So what's 3 times 4x?
12.
What's a negative 18z times 3?
Negative 54.
Thank you. And what's 34 times 3?
102.
102. Okay. Now I have to look at my other equation. Since I got my 12x, that's what I wanted. I'm going to wait on this guy for now. Let's go back to the other green equation.
So now we're trying to get negative 12?
We're trying to get a negative 12, so when we add them together, they'll cancel.
Times by 2.
Yeah, so if we take this equation times 2, we're going to get a negative 12x right there. So I'm going to say times negative 2. So I'm going to do, let's do the work below, and we'll put it at the top. Times negative 2. So you got negative 2 times
Negative 6.
positive 6x. Sorry, guys. Okay. So what do I get when I distribute? What's 2 times negative 6x?
Negative 12x.
Okay. What's a 2 times 25z? Equals, what's 2 times negative 49?
Negative 98.
Negative 98. So I got my 12x, negative 12x. Perfect. Let's add those two together.
You add them.
Yeah, we're going to add them. Because what operation do we do to cancel a positive 12x and a negative 12x? You add them, right? Oh. So 12x minus 12x, gone. What's a negative 54z plus 50z?
Negative 4z.
Thank you. 102 plus negative 98. Positive 4, right? Okay. So we have negative 4z would equal 4. How do we get the z by itself? Okay, divide by negative 4. So z would equal negative 1. It's about time. I finally figured out what one of my variables was.
I have to find.
Z equals negative 1. So once I found out what one of my variables equals, how do I find out what another variable equals?
Plug it in.
Plug it in where?
To this
To my.
So I wish I could plug it into one of these.
Your one that you have.
You
green
do
dots.
Yeah.
The one of the
So I'm not going to plug z equal to negative 1 into this equation, because if I do, I'm still going to have two missing variables, x and y. So let's plug this guy into one of the green dot equations. So I'm going to erase some of this mess.
So you don't need all that anymore?
All this stuff? Well, that would be my work, but kind of running out of board space.
Okay.
Is that okay?
Yes.
Okay.
Got it all.
I'm just going to leave my nice green equation. So, z equals negative 1. Let's plug that into this equation. Z equal to negative 1.
Because you don't really have to plug it in, so it's just negative twice over. Like you don't have to do all the steps for it, right?
Right, you don't have to do all the steps, right? But I'm going to just show you guys. So I'm going to do 4x minus 18 So all I did was took z equal to negative 1, and I put it in right here for z. I could have done it in this equation too, but this equation has bigger numbers. Either way would have worked. So what's a negative 18 times a negative 1?
Positive 18.
Okay? We have to find x, y, and z.
At least this was shorter.
It is shorter. If you compare, I think it is a little shorter. We're going to do more examples. So if I have 4x plus 18 equals 34, how do I get the x by itself? What should I do first?
Subtract 18.
Thank you. I know it's a lengthy process, I know. Yep. Z equals negative 1. X equals 4. We are on the home stretch. How do you find what y equals?
Plug it into the y equals equation.
So let's plug it into one of the original equations we were given. The reason why we're not substituting x equals 4 and z equal negative 1 into one of these green dot equations is because we're trying to solve for y. These two equations don't even have a y in them. So we have to pick one of these three. I'm just gonna pick the second one since it has smaller numbers. So, way up at the top here. Negative 2 times x.
So,
X was 4.
Could
I
you
think.
do any of them?
Yeah, yep, you can pick whichever one you want. I'm gonna do the second one.
I did the y equals 9 plus 2x minus 4z. Can you do that?
You did this one?
Yeah, after it was like, I moved y by itself.
So you got y by itself. Did you get this too, Natalie? Are you on the same step or are you back up? Okay.
No, I finished it.
So you put this into the second equation.
No, I did put it
She
into
put it
y
into like
equals
the-
negative 9 plus
Yeah.
2x minus 4z.
she
Can you
put
do
it into
that?
what we had, she put it into the
You already erased it,
Yes.
but.
Oh, you could do it in that one if you wanted to. Yeah.
Okay,
Yeah.
that's all.
You should get the same answer. See if it matches. So negative 2 times 4, since that's our x.
Really?
Yep.
I love it. Plus.
And what was our z?
Negative 1.
Oh, we have to plug in the z too?
Yep, that's plug in the z. Yep. So again, we only have one variable, y, so we can find what y equals. Tyler told me negative 2 times 4 is negative 8. Awesome. What's 4 times negative 1?
Negative 4.
Okay. Combine like terms, so you have a negative 8 and a negative 4, so you have a negative 12. So you have y, I know that's hard to read, y minus 12 equals negative 9. Add 12 to both sides, right? Natalie, did you get y equal 3?
Yeah.
Cool. All that work, I know. On the test, I'm not going to make you do 5 or 6 of these. There's going to be 1 or 2.
2. Just do 1.
Or 6. Depends how we do in class.
Just do 1.
Depends how much we're paying attention.
1.
It'll probably be 1 or 2. So, we could write our answers as z equals negative 1 and circle it, y equals 3 and circle it, x equals 4 and circle it. What's another way we could write our answer?
X, Y, Z.
X, Y, Z, an ordered triple. 3 terms, triple. So 4,
3.
yep. If you really wanted to check your answer, what are the 2 ways you could do it?
And plug it all
Plug it
back
in
in.
the dead.
Plug them all into the equation and see if it works, or use Desmos.
Can you plug it into